Today we're looking at the surface area of pyramids and cones. Our goal is to find the surface area of pyramids and cones. We will start with some pyramid vocabulary. We have the height. That is the perpendicular distance from the base of the vertex to the top. Okay, so the height goes from right here. Okay, the middle of the base up to the vertex. On the side, we have the slant height. This is the height of a lateral face. A lateral face being a face that is not the base. It kind of rhymes, doesn't it? The variable L is used for slant height. Why L? I have no idea. Maybe for the L and slant. Important, though, to keep these two separate. Height versus slant height. Now, to find the surface area of a pyramid, we do it the same way we found it for other shapes. We just add up all the areas of all the faces, including the base. So we're going to go ahead and find surface area of these pyramids. So, first thing I see with this square pyramid over here is that the area of the base will just be 8 times 8. That's going to be 64. Now, what's nice with the square pyramid is that all of our other faces will have the same measurements. Okay, the base is going to be 8, and the height, the slant height, of that triangle is 12. So to find the area of a triangle, we just do 1/2 times the base, which is 8, times the triangle's height, which is 12. And we know there's 4 of these, okay? 4 sides to a square pyramid. So we can say just times 4, save ourselves some work. Well, if we look, 1/2 and the 4, well, 1/2 of anything really go away. So we can simplify anything we want here. So let's just say 1/2 and 4. Cut those down to make it 8 times 12 times 2 by just doing 1/2 times 4. Okay, so 8 times 12, we should know is 96. And we double that to get a surface area of 192 feet squared. Okay, we're still talking about area, so we're going to do feet squared. Now we have this one. We have a triangular pyramid here. And we are in luck. We're told that the area of the base is 62 4/10 of an inch. So we can go ahead. We know that the surface area, well, actually, you know what? That doesn't matter for us. That's for volume, another lesson. So let's go ahead and find the surface area of this shape. So we see that the slant height is 10, and we've got base of 12. And it works out nicely. We've got that all the way around. So we've got 12 times 10 times 1/2, okay, because that's the area of the triangle. And we've got 3 of those triangles. So we take whatever this is times 3. Okay, we can do multiplication, and we want to do it. So 10 times 1/2 is 5. So 12 times 5 times 3 gives us 60 times 3 equals 180. Now that takes care of our lateral faces. Now we've got the base, which is a triangle. So we know for our triangular base right here, we've got a base of 12 and a height of 12. So we do 1/2, 12 times 12, which is 1/2 of 144. Again, any order you want to go in for multiplication, which gives us a base surface area of 72. Add these together for a total surface area of 252 inches squared. Now we're on to cones. A little more involved here to find this formula. So we have a net of a cone, which is right here. After the circular base, we have our area equals pi r squared. We know that will be part of our formula. But now we'll consider the lateral part of our cone. Here's the lateral area. right here, the lateral portion, I should say. Well, we notice that we've got a rounded part of our cone here, part of this net. So to find circumference of that part, is going to be circumference equals pi d, or pi times 2 radius, or 2 pi r. Excuse me. Now we look at our shape, and we notice that only one part of that portion is rounded. So therefore, we only use one radius times pi. Okay, we know for cylinders it's 2 pi r. Only one radius times the pi. And we take this and multiply it by the slant height. So we just say pi r times our slant height, which is L. We combine this with the area of the base to get our cone surface area formula, pi RL plus pi r squared. That's the formula we're going to use to help us find the surface area of this cone. So we notice that we have a cone with a radius. Okay, hard to see. That is the radius of 6.5 meters. And our slant height is 21 meters. So we go ahead, write out the formula. Pi RL plus pi r squared. Let me move this cone over like that. You guys get the idea. That's the radius. Don't need that anymore. And I mentioned we're going to use 3 1400ths as pi. So we got 3 1400ths times the radius of 6.5 times the slant height of 21 plus 3 1400ths times the radius squared, 6.5 squared. Not easy to do mentally. So we just go ahead now and simplify using, hopefully, our calculators, which you all have. Okay, so we add up the first one, and we get multiply the first one. We get 428 and 61 hundredths. And we're going to add that to 132 and 665 thousandths. Unless we're asked to round, please don't do it. And the sum of these gives us 561 and 275 thousandths millimeters. Again, you'll probably be asked to round on these, but if you're not, don't do it. This concludes your surface area lesson on pyramids and cones.